Okay, so the concept for this video is vectors versus bitmaps. We're going to learn how they work and also between the two file formats, which is better. Okay, so let's take a look at a couple images to illustrate the difference between vector and bitmap images. I have a vector image here, which is a smiley face, and you can see that as I hover over various parts, it will highlight the various regions. So I've got two circles for the eyes, one large circle, and this smile. And then when I go to the bitmap image, it's just all one solid image. So the difference here is that the vector image, the way that it stores the image is as a bunch of shapes, and using math, it can scale them. So the ellipse, all it needs to know is the position and the size. Same thing with this exterior one, and it keeps track of the interior color. This line here has 3 points on it, and if I click on this, I can use the pointer here to do some different things. So when I change the slope of the mouth to a variety of different angles, this is something that vectors are very good at because there's a mathematical formula here that controls the angle of this slope right here at the bottom. Whereas with the bitmap, I can't really do any of that because it's all one solid image. Okay, so let's do some zoom ins. What I've got is I've got two other versions of this that have been saved. So this is a vector version of the happy face, but it has been zoomed out to oh, it's just taking a minute to load here because these are very large. The last one was 400 pixels by 400 pixels. This one is 10,000 by 10,000 pixels. So clearly it's having a bit of a lag opening here. Okay, so we finally loaded. You can see the 10,000 by, this is another 10,000, and it's zoomed out to 6%. So I'm going to zoom it in a little bit, and then I'll go in a little bit further. So you can see this mouth line here is unbelievably crisp. We could blow this up to resolution of 11 billion by 11 billion, and it would still have a really smooth line because you can still see the arc here. And because vector images use math to scale the images, this will be a perfect line no matter how big that I make this. I can make the smiley face big enough to fit on the side of a building, and yeah, I'll still get this nice crisp line. So I'm going to open up the similar image, but it's a TIFF, which is a bitmap format here. And with this one here, I'm going to zoom it in, do the same thing. Go to 25%. And you can see already at 25%, we get this foggy haze that's around the edge here. I'll go up to 100. And you can see how blurry this is. Now, the reason that it does this, I'll illustrate with the other image here. So I'm going to put on a grid. Now this isn't legitimate, but it'll give you the idea of how a bitmap image works. A bitmap image is divided into pixels, and each pixel is basically a map of what each color of each pixel is. So it kind of works like a grid. So it knows that this one's black, this one's black, this one's black, this one's black, and then the ones to the left of it are yellow. But if I double the size of this, now there's going to be a gap between these pixels. So it has to figure out, okay, what color should I put there? So it's going to put something kind of halfway between black and yellow, kind of like this. So this pixel it knows is going to be yellow. This pixel it knows is going to be black. But for the ones in between it, it's not sure. So it kind of does this foggy haze that we see here. So for this, very crisp. For this, not so crisp. I'm going to turn off my grid, and I'll show you an example of something that is best displayed as a bitmap image. So I've got this sky image done by Flickr user Peter Harrison. So if I go up to 100%, you can see that to kind of communicate the complexity of a skyline here, we can't really use math. We can't say, okay, there's an arc here, and then there's 9 other colors that it turns into as it fades into the sky. There's no mathematical equation that will efficiently model this kind of thing. So when you're doing photographs, those should remain as bitmap images because the vector version of this it'll be a lot more simple and less nice to look at. So let's take a look at the files here. So I've got a few different images here that are all saved. The face bitmap is a TIFF image and it's quite small. The vector here is surprisingly it's larger, the small one, and then the big ones you can see a huge difference. So I'll just organize them by their size. So you can see that the smallest image size here, and we'll ignore the sky image because that's not part of our comparison. The smallest image here is the bitmap of the smaller happy face. So it runs about 46 kilobytes. And then the vector image at 400 by 400 is roughly about 5 times the size of that one. But these are both unbelievably small files, so if you were to put these on a website, both of them would load in literally no time. But if we take a look at the comparison between their larger counterparts, the large vector image, which is 10,000 by 10,000 pixels, is 1.5 megabytes. And the TIFF image, when we blow it up to 10,000 by 10,000, it's a whopping 12.2 megabytes. So sometimes, when you're taking a picture with your camera, the file sizes will be quite large, just like this. So you can see that there's a huge difference. Now, the interesting thing is when I scaled the image, it took a long time for this computer to convert the vector to a very large size because it had to do a lot of math there. But when it converted the TIFF to a larger size, it did that relatively quickly. But if you're loading these on the internet, obviously a smaller file size will load faster than a larger file size. Okay, and just finally to review, we answered the question about how bitmaps and vector images work. Bitmap is a color map for the individual pictures of the image, and a vector image is equation-based, so it deals more with points, coordinates, and mathematics to do things like lines connecting coordinates and things like that. We also talked about which is better in terms of vectors. They work very well for graphics like logos and icons and cartoons. They usually have a smaller file size, and they maintain really high quality when you scale them or when you alter the image, like when we wanted to change one of the paths between 2 points. Now, bitmaps are still very useful, especially for photos, and as I found out, they are faster to process a scale. So when I was blowing up the happy face image to a much larger size, it was faster to do that. So remember that vectors and bitmaps are different, and you need to consider which one you're going to use for what instance.